All right, so this video is going to be over classifying real numbers. So classifying numbers is just categorizing real numbers according to whatever shared qualities that each number has. So there's going to be some vocabulary to get out of the way first. So the first one is natural numbers. So go ahead and write this in, natural numbers, or just natural, actually. So natural numbers are positive whole numbers. So whole numbers, so no decimals, no fractions, starting with 1. So natural is going to be this little bubble right here. And they're whole numbers, and they start with 1, so that means 1, 2, 3, 4, 5, 6, and going on. As long as it's a whole number, doesn't include negative numbers, and it does not include 0. So those are natural numbers. The next one are positive whole numbers, kind of like natural, except it starts with 0. So natural starts with 1. Whole numbers, which is this bubble right here, whole numbers, starts with 0. So we got 0, 1, 2, 3, 4, and so on. As long as it's a whole number, it includes 0. Again, no fractions, no decimals, and no negative numbers. All right, so next is integers. So integers are also whole numbers, including though their opposites. And what they mean by that is they're negatives. So it's any whole number, such as, let me go ahead and write an integer. And then, so we got 0, 1, 2, 3, 4 going on. Notice it does have 0. And then the negative whole numbers, such as -1, -2, -3, and going on. So -4, -5, keep going, as long as it's a whole number. So those are integers. All right, next is what are called rational numbers. And it says all these numbers can be written as a repeating decimal and terminating decimal. All right, so repeating decimal means that it's a decimal. So a decimal that repeats itself. So if, let's say we have 1/3, so 1 and 1/3, if we type that in on the calculator, we're going to get 1.3333, and it goes on forever. Or you can just put 1.3 bar. So bar means, remember, that means repeating. So 1.333, so that's a decimal. It can be expressed as a fraction or a decimal. And that's what a repeating decimal is. A terminating decimal means that it's just a decimal that ends. So let's say, for example, 1.25. And then move that up a little bit, 1.25, and then that's it. It doesn't go on, it terminates, so it ends. So this is going to go right up here. So we got the rational. So for example, 1.25 would be up here. 3/4 would be up here, but of course we would convert 3/4 to 75/100 or 0.75. So you always want to convert everything to a whole number in decimal first. And also the repeating one, so like the 1.3, so anything that's repeating, so 1.3 bar, that's also a rational number. All right, and then the last one is all these numbers can be written as a non-repeating and non-terminating. So non-repeating means that it doesn't repeat, because if a decimal does repeat, it's considered rational. So this is what's called irrational. This is going to be over here. So it's irrational numbers. All right, non-repeating meaning that it doesn't repeat. Non-terminating means that it goes on forever. So basically, it goes on. It's a number that goes on forever. So such as 1.23794 ... If you ever see, let me move this up a little bit. If you ever see these 3 dots down here, which is called an ellipsis, that means that the numbers go on forever. So if they're not repeating, so if you don't see a bar and these numbers are just continuously going on, that means that it's an irrational number. So you have to convert all numbers to a whole number in decimal first. So that way, if you can see if they are repeating, because if they repeat, then it would be considered rational. And if it didn't repeat, but it also never terminated, meaning that it never ended like 1.25, and then bam, it stops or something after that, that means that it would be irrational. So a good common example is something like pi. So pi, we have to type that into the calculator, and we get 3.14159 dot dot dot, and it goes on forever. So pi would go in this category here. All right, before I move on to the next page, one thing I do want to point out is not only do you have to know where numbers are categorized, but you have to know how each one of these types of numbers relate to each other. So, for example, we can look at the number one. The number one is a natural number, but it's also a whole number and it's also an integer, meaning that it's also rational. So, you always start from the bottom of the bubble. So first step is you're always going to convert your number to whole number and decimal. So let's say we just had number one. So we had number, let's go to two. We had number two. So we're going to start from the bottom. Does two fit into the natural section? Yes, we can stop right here. So two fits in natural. That means that two is also a whole number. It's also an integer. It's also rational, and it's also a real number. But if we were going to do pi, always start from the bottom. So pi, so we come here, 3.14, it's repeating. These are only whole numbers, so it can't be that one. We'll move up to the next one. Can't be here because these are whole numbers as well. Whole numbers. All right, these are fractions. Fractions and decimals. Some fractions and decimals fit into rational. However, remember, if we're categorizing pi, we have to ask ourselves: does it repeat? No, pi doesn't repeat. Pi goes on forever, but it doesn't repeat. So that means if it goes on forever, it doesn't terminate like 1.25 does. So pi would have to go into the irrational section. So pi is irrational and it's a real number because everything in this bubble is a real number. We'll get more into that onto the next page. Let's go ahead and go to here. I'm going to go ahead and label. So we got natural, whole, integer, rational, irrational. All right, there is also another visual. So there's two visuals we can kind of look at that are kind of helpful. So notice natural starts from the bottom and goes up if you're using the bubbles. And then over here, you have like these little hoop things, these little basketball hoop things. You throw numbers in there. So but this time you start from the top and go down. So bubbles start from the bottom, go up. This diagram starts top and goes bottom. All right, so let's say we're going to compare the number 16. So that means we're gonna start right here, the bottom of the bubble. So 16 is a natural number because it is one of the counting numbers. So remember the counting numbers are 1, 2, 3, 4, and going on. They're whole numbers. So 16 fits right here. That means 16 is also a whole number, it's also an integer, and it's also rational. And then coming over here, if we start from the top, if we were to throw the number 16, can we throw it into the natural? Yes, we can because it's a whole number and it's not zero and it's not negative. So we can throw 16 up here. So that means if we throw it up here, it's going to fall through all of these hoops. So that means that 16 is not only is it natural, but it's also whole, it's also an integer, and it's also rational. So 16 would go in this spot right here. P16 in this the natural section. All right, let's take a look at 3/5. So 3 divided by 5, if we don't know what that is, we have a calculator. We can always type it into the calculator. So 3 divided by 5, you get 6/10 or 0.6. All right, again, so you start from the bottom. So 0.6. So we're looking at 0.6. 0.6 is a decimal, so it can't be natural. It can't be a whole number because whole numbers don't have decimals. Remember, integers have the negative numbers. Go ahead and just write these in. 0.6, so we've got to move up one. Doesn't fit in this category, we've got to move up one. Again, integers are also whole numbers, so we got to move up one. All right, so now we're in rational section. So we got to ask ourselves, does 0.6 terminate, meaning that does it stop or does it go on forever? Well, 0.6, if we type in 3 divided by 5 on a calculator, we only get 0.6, meaning that it does terminate. So 0.6 or 3/5 would be in the rational section. So that means 3/5 is a rational number and it's also a whole number. Notice that you start from the bottom and go up. When I say 3/5 is rational and a real number, notice that I can't go backwards. So 3/5 is not an integer and not a whole number and it's not natural. It's only going up. However, it is possible, it is a fair statement to say, well, rational numbers, well, it's for example, like natural. So it's natural. It's normal to say, it's okay to say, I should say, it's okay to say that natural numbers are also rational numbers, but not all rational numbers are necessarily natural numbers. Meaning that 3/5 is rational, but it can't go down because it starts right here. So coming over to this section over here, 3/5, the decimal. So can I throw it into this hoop? No, I can't. So I gotta go down. Can I throw it into the whole number section? No, I can't. Integer? No, but I can throw it into the rational. So 3/5 would go here too. So it's rational. So, and it also falls through the real numbers. So just like up here, it's rational and it's a real number. So here, it shows us the same thing. It's rational and it's a real number. So hopefully you're understanding how that works. All right, come down here to square root 49. So square root 49, sometimes when we type in a bunch of square roots in a calculator, we always think we're going to get a weird decimal number. That's not always the case. You always have to convert all numbers on the calculator to a whole number in decimal form, just like we're ordering real numbers. So if we have root 49, type it in the calculator, you should get 7. So that means, start from the bottom, can we throw 7 into the natural section? Yes, we can. So we can stop right there. So that means 7 is also natural, it's a whole number, it's an integer, it's rational, and it's a real number. So 7 is all of these categories, everything except irrational. So you got to be careful with that when you're taking a test. You have to know how numbers relate to each other. So all natural. So let me just say this one again. So all naturals are all natural numbers are whole numbers, but not all whole numbers are necessarily natural numbers. And a good example is 0. So 0 is where it stops. So notice how 1 and 1 share this bubble, natural and whole, but 0 doesn't, because 0 is not a natural number. All right, so like we go to 0, like I just said, 0 is not natural, so we've got to go up 1, so 0 would fit into the whole number section. So that means 0 is a whole number, it's also an integer, it's also a rational, and it's also a real number. So if you were ever asked the question, how does 0 relate with all the other classifications, you would be able to say, well, 0 is a whole number, it's an integer, it's rational, it's real, but it's not natural, and it can't be irrational. So that's how you would do those. All right, be careful with your percentages. Remember I said you have to convert them to decimal first. So if you have 13%, you got to move that 2 decimal spots over, so you get 0.13. So 0.13, it's not natural, it's not whole, it's not integer. It has to be rational because it's not repeating, and it terminates. So 13% would be up here. -5. Can't fit this category, can't fit this category. It's an integer, so -5 would go here. So -5 is an integer and rational, and it's real. Okay, we got 1.33 repeating, so that's the example that I gave. So we said start from the bottom, can't go here, can't go here, can't go here, but it fits here. Repeating numbers, so refer back to your notes if you have to. So repeating numbers is rational. All right, so -3.65. don't have anything repeating. It does terminate, so it has to go into the rational section. So if we start from the bottom, or if we come here, can't throw it into natural, can't throw it into whole, can't throw it into integer, but we can throw it into rational, and that means it's also real. Negative. Notice that even though that it is negative, it's still not an integer. So don't confuse that. Just because there's a negative sign doesn't necessarily mean that it's an integer. You have to go by, is it a whole number or does it have a decimal? Is it repeating? Something like that. So negative 3.65 would land in the rational section. All right, again here, so we would type this in as 8 plus 1 divided by 3. You should get 8 point repeating 3. Remember, a repeating decimal falls into the rational. Negative 1%. Don't confuse this as a whole number. Remember, we have to convert everything to a whole number in decimal. So negative 1%, we have to convert by moving 2 decimals over to the left. And we get negative 0.01. That's a decimal that terminates. So that would be irrational. So that's that. 8.3 we did. Okay, root 17. Let me type that in on the calculator. I get 4.123105626. Okay, so it's a long numbers. So that means, I'll just show you my calculator here. So I get this. It looks like it terminates, but the calculator isn't always going to express everything. When you see something like this on your calculator, like a whole bunch of digits, usually like 8 or 9, that means that it's going on forever. So root 17 is going on forever. So root 17, we can put into the irrational section. If it goes on forever, meaning that it doesn't terminate, it's irrational. But don't confuse it with repeating. So remember repeating decimals, repeating is right here. Repeating decimals that has the bar, repeating does go on forever, but if it repeats, it goes into the rational section.